G'day, welcome back to Acro Lab. My name's Tim and this is episode 4. Today we're going to take a little bit of a different direction than the previous episodes and we're going to do the first of our deep dives into water chemistry. So today's episode is going to focus on how I go about major element dosing in my reef tanks. So I use a bit of a hybrid Frankenstein approach with multiple delivery methods for calcium, alkalinity and magnesium. I talk through each of those methods in terms of their benefits and disadvantages today. And also at the end of the episode, there's a little bit of a hidden gem in terms of my method that I use to design my own 3-part solutions, which is a nice cost-effective way of being able to dial in your water chemistry and have a bit of fun along the way. So today is a little bit of a nerdy session, so I hope you don't get too bored with that. If you're not into sort of water chemistry, maybe tune out now and I'll see you on the next episode. But if water chemistry is your jam, then I hope you enjoy this. I'd love to hear from you. Leave some comments below on any questions about today's topics, anything you do differently. You know, as I've been mentioning in previous episodes, there's many different ways to reef. This is just my own. I'm not saying it's any better or any worse than what other people do. Is the principle of this channel, complete transparency. I'm just putting it out here. This is the way I do it. I'd love to hear from you. I'm always open to tuning and changing the way I do things. So if you see anything you think I could do a little bit better, drop a comment and let's have a chat. Anyway, enjoy the presentation today and talk to you soon. All right, in this session of episode 4, we're going to look at major element dosing. The things we're going to focus on are obviously calcium, alkalinity and magnesium, and how I go about getting these particular major elements dosed into my tank. We'll talk about both kalkwasser in terms of a heavy lifting agent and the flexibility of the balling method. And we'll wrap up the episode with how to go about designing your own 3-part solutions. So, why do we dose major elements into the tank? It's always good to question what we're doing, why we're doing something, and if we understand the why, then we can design the how. So obviously SPS corals consume calcium, carbonate and magnesium, carbonate being the representation of alkalinity, as major elements. And as hobbyists, we need to replenish these 3 major elements back into our reef tanks at a rate equivalent to the consumption of those elements by the corals themselves. So there's many ways to go about dosing the major elements. You know, there's a calcium reactor, there's kalkwasser, there's 2-part, there's 3-part, there's derivations of up to 4-part, there's the balling light method, the balling method, and we'll cover up on some of these today, and in particular the ones that I'm currently using in my tank. And I've actually tried pretty much all of those ones I've just mentioned, and the ones I've settled on now are the ones I talk about in this presentation. A calcium reactor and calc are both cost effective at scale. So the bigger your system, the more large colonies you've got, the more alkalinity, carbonate and magnesium consumption you've got in your tank, the better off you're going to be from a cost effective point of view with a calcium reactor or kalkwasser. A downside of those 2 methods are they don't readily replenish magnesium. You can put magnesium chips into a calcium reactor. I've tried that, and I still found myself supplementing magnesium when I did that. The other challenge with calcium reactors and calc is that it's difficult to maintain an ionic balance, and we'll go into what that means later in the presentation. And you can't dose calcium and carbonate at separate rates. They're fixed ratios you dose them collectively as a 1:1 molar ratio. All right, so let's talk about ionic imbalances, particularly related to 2-part and 3-part solutions, and how this has led to the development of the balling light and the balling full method. So I've got a little chart here which across the top axis we've got some various salts that it can be that are basically the major constituents of 2-part and 3-part. So in a 2-part solution we have calcium chloride dihydrate and we have sodium bicarbonate, and when we dose those two elements, so the calcium chloride and the sodium bicarbonate, the corals are interested in the calcium from the calcium chloride and they're interested in the bicarbonate from the sodium bicarbonate. And that leads us with an excess of sodium chloride. A 3-part solution doses those same elements, so the calcium chloride dihydrate and the sodium bicarbonate, and then one or both of magnesium chloride hexahydrate or magnesium sulfate heptahydrate. The benefit of dosing both the magnesium sulfate and the magnesium chloride is you have less excess chloride build up in your tank. So the main difference between the 2-part and 3-part is the addition of magnesium. But as I discussed, what the SPS are consuming in each of those 4 salts or 4 elements is the calcium, the carbonate and the magnesium, as shown on the first row of this chart. And the residual elements are shown here circled in red, which is an excess of water and sodium and chloride. So the further that we continue dosing our 2-part or our 3-part solution, we get an excess of sodium and chloride which bind together to create a sodium chloride salt, as shown in the bottom left corner. And then we continue to dose and we get more excess sodium chloride, and we continue to dose and we continue to get a residual buildup of sodium chloride in our system. And so if we think about the total salinity of our system being 35 ppt, the representation on the left just shows a series of coloured balls representing the different salts in our tank, and sodium chloride makes up by far the biggest individual salt in a reef tank, and so that's represented by the red balls. And then we've got other coloured balls here. We've got, say, calcium carbonate as blue balls, we've got magnesium sulfate as green balls, we've got potassium chloride as yellow balls, and so on and so forth. And if we go down the path of the 2-part or the 3-part solution, then we're going to end up with an excess of sodium and chloride, and that's going to continue to build and build till we end up in the image on the right, where we've got so much excess of sodium chloride that we don't have any space left for these other constituent salts that make up an ionic ratio similar to natural seawater. And look, I've gone to the extreme on the right-hand diagram just to demonstrate the point. I don't think you'd ever end up with just NaCl salt, or you'd be in a world of pain for your SPS. But I guess what I'm showing here is that this is the ionic imbalance that comes about by just running a standard 2-part or 3-part solution. And that's where the balling method comes into play. So the balling method looks at the addition of non-sodium chloride salts. So outside of sodium chloride, we have all these other natural salts that maintain a natural seawater ionic balance. Things like calcium carbonate, potassium chloride, magnesium sulfate, etc., etc. So that way, for each excess sodium chloride we squeeze in with a 2-part or 3-part, we're also making sure that the ratio of those other salts are maintained. things like magnesium sulfate, potassium chloride. Now, there are products on the market that produce these non-sodium chloride salts. They're readily available and they're quite cost effective. Personally, I use the Aquaforest Reef Mineral Salt, and what it does is it's all of the salts in natural seawater minus those sodium chloride ions. And so if you dose that non-NaCl salt along with your 3-part solution, then you're going to get an overall ionic balance in your system that's similar to natural seawater. So look, the pros of this type of a method is obviously the ionic balance, so that your salinity is maintained but your ion ratios are maintained. But the real benefit of having a 2-part or a 3-part on dosing channels is there's heaps of dials to tune. So how we talked about before about kalkwasser and calcium reactors having fixed molar ratios, and you can't alter your calcium with respect to your carbonate. With the 2-part, 3-part, you can alter so that you have a little bit more alkalinity than calcium or a little bit more magnesium than the other ratios. And so depending on what your individual consumption of your reef tank is, you can dial that right in. So you've got that flexibility in dosing calcium and alkalinity at separate rates. A big con though, or a big negative of a 2-part or a 3-part is it can be costly at scale. And especially if you're buying off the shelf. You pay the reef tax, and it's okay in smaller systems or moderate sized systems with small to moderate SPS demand. But if you get into a moderate to large system or a high SPS demand, it can be quite expensive to maintain over time. The other thing that I look at in my method is kalkwasser, otherwise known as calc. And kalkwasser is just simply calcium hydroxide. And you add that to your reef tank, and it binds with the carbon dioxide in the reef tank to form calcium bicarbonate. And essentially what that does is it removes the CO2 that's bound up in your reef tank, and in doing so it drives the pH up. So it's not the kalkwasser itself that drives pH up, it's the removal of CO2 to form the calcium bicarbonate. And so if you think about pH, it's technically, from a scientific point of view, the abundance of hydronium ions in a solution. But in a reef tank, hydronium is essentially controlled by the abundance of dissolved CO2. So when we refer to pH, we're basically talking about how much CO2 is dissolved in the water. And at a higher pH, this allows for easier calcification. And a lot of people talk about that optimal zone of about 8.1 to 8.4, where calcification, and particularly in SPS corals, is at their best. And the other thing to consider is the more kalkwasser, the higher the pH, the easier the calcification, the more demand that you have for those major elements in your tank. So it's a bit of a cycle there of generating growth and consumption. But there are some pros and cons of calc. So one of the big pros that I find for my system is it's highly cost effective. I think in terms of all of the options that I mentioned at the start of the video, kalkwasser is probably by far the most cost effective. There's the benefit of increasing pH, which, as I said on the previous slide, helps improve calcification and drives demand for consumption. It's really easy to hook up to a doser. It can do the heavy lifting of calcium carbonate dosing. It doesn't cover magnesium, but can be implemented to do a bulk of the calcium carbonate consumption in your tank. There are multiple ways to produce it. You can use a calc stirrer. I just use a slurry in a big 100-litre vat, and then just use a a dosing pump to drip feed that into my tank. So I dose about 3 litres a day currently, which is just slightly less than my evaporation rate in my tank. I guess the big pro for me though is Calquos has been around for a long time. You know, we're talking decades, and it's trusted by some major players on the SPS scene, people like Tidal Gardens, Worldwide Corals. You know, there's heaps of videos on YouTube about Calquosser and its use from farm scale right down to individual tanks. So lots of pros around Calquosser, but there are also some negatives as well. And one of the biggest talked about deficiencies of Calquosser is you can only dose it up to your daily evaporation rate. So that basically puts a hard deck on how much you can put in it. Even if your consumption is higher than your daily evaporation rate, you can only dose up to that rate. Obviously, it doesn't deliver magnesium macro or trace. So it's really only focusing on calcium and carbonate. It also has a very high pH of approximately 12, so you need to be careful with handling and dosing. And there are seasonal adjustments to evaporation in your tank, which can lead to headaches if you don't have a finely tuned Calquosser input off balance or offset with your auto top off. So what I try and do is actually use a bit of a Frankenstein of all the things I've talked about here today, which is why I've got the image of Frankenstein up there in the top left. So I use a bit of a combined 3-part balling and calc method for the flat. And I've got a bit of a chart here to explain why I do that. So first row, I use a 3-part. So I've got the calcium chloride dihydrate to provide calcium into my tank. And I've got the sodium bicarbonate to produce the bicarbonate. And then I dose both the magnesium sulfate heptahydrate and the magnesium chloride hexahydrate to get the magnesium. I don't get an ionic balance out of the 3-part alone. And its role is to give me some dials that I can fine tune my calcium, my carbonate, and my magnesium to get it right on point so I can get my trends nice and stable. However, on the bottom row, I've got my Calquosser, which is there to do the heavy lifting. So calc does a bulk of my calcium and carbonate input into my tank on a daily basis. And then on top of that, the 3-part probably makes up about 15-20%. The calc makes up about 80%, and I've got that dial that I can tune. So I don't tend to tune my calc very often. The rate stays pretty steady at just below that rate. And really, what I'm playing with is the daily dose rate of my 3-part. So as my consumption grows, I dial that up to meet that higher demand over time. And then I also put in the non-NaCl salts. I use the Aquaforest Reef Mineral Salt there to try and get a maintenance of ionic balance. And I play with the rate of consumption on that with respect to looking at my monthly ICPs and making sure that the ratios between all the major elements are relatively consistent with natural seawater. So that plays the role of balancing out those ions so I don't get an excess of sodium and chloride build up on time. So I tend, when I get my ICP back, the first thing I look at is my sodium and chloride to make sure it's not creeping up. So that's sort of my combined hybrid Frankenstein method that I'm currently using. And as I mentioned about a con or a negative of 2-part or 3-part is that it can be quite expensive if you buy it off the shelf. And so that's why I've gone down the path of designing my own 3-part solution, which I mix up batches every month or two depending on how my ICP results look. So I've got a bit of a rough menu here of how I go about dosing it. Look, there's heaps of literature on reef to reef and and other sites about how to do this. This is my own basic methodology. And look, feel free to give it a try if you want, and let me know how you go. So look, I basically start with my particular salt. So let's look at, as an example here, the calcium chloride dihydrate. And based on some basic calculations and looking at your ICP, you estimate your daily consumption of calcium in this case. So for me, it's about 5 ppm. And then I multiply that consumption by my tank volume and by a dosing or dialing factor, which is currently set at 40 for calcium for me. So if you take that equation and just the next line sort of follows that through, so 5 ppm multiplied by a tank volume of 500 litres multiplied by my factor gives me a target concentration of about 100,000 ppm. So I'm trying to achieve in my stock solution. So I make up 2 litres of this at a time. I'm trying to achieve a 100,000 ppm solution. So the next piece of the puzzle is you need to get your molar masses or your atomic weights. So the atomic weight of calcium is about 40 grams per mole, and the molar mass of calcium chloride dihydrate is 147 grams per mole. So the mass fraction of calcium is simply that 40 grams per mole divided by the molar mass of calcium chloride dihydrate, which works out at about 0.27. So what that means in simple language is about 27% of the calcium chloride dihydrate salt is actually calcium. So if we want to get 100,000 ppm, we have to factor in that 73% of that salt isn't calcium and only 27% is. So to work out how many grams of salt to put into your RODI solution to make this up, you basically take that target concentration, 100,000 ppm, and that's ppm or milligrams per litre. So to get to grams per litre, we divide that by 1,000, and then we divide that number by the mass fraction, which is 0.27. So therefore, we get about 367 grams of salt, of that calcium chloride dihydrate salt, per 1 litre of RODI solution. Now the next thing you'll want to do is you want to check the solubility of that calcium chloride dihydrate, which in this case is about 745 grams per litre. And the reason we do this is if we wanted 360 grams of salt, but the solubility of calcium chloride dihydrate was only 200 grams per litre, then we wouldn't be able to get we wouldn't be able to dissolve all of that salt in the solution. There'd be an excess of the salt at the bottom of the beaker, and so you wouldn't be able to make use of it all. So always check that solubility, and in this case we're all good. And I guess a main point here is you can adjust that factor. So that factor of 40 that I currently use, it's a comfort level based on my dose rate and how often I've got to basically make up the stock solution. So you can play with that. You don't want your target concentration to be too low. Like if we had a target concentration, say here, of 10,000 ppm, then I'd have to dose 10 times more each day than if I had a higher concentration. So other factors I use currently, so my current factor for magnesium is 28, and for ALK it's about 10. And as I mentioned a couple of slides ago, I tune those daily dose rates based on the weekly trend of my daily alkalinity, calcium and magnesium peaks from my apex trident. So I'm looking at those peaks each day, but then I'm zooming back out a little bit and I'm looking at the weekly trend of those peaks, and if that weekly trend is dropping, then I'll dial up my dose rate. If that weekly trend is increasing, then I'll dial it back. If it's pretty stable, I'll hold it as is. All right, so that brings us to the end of today's presentation on how I go about dosing the major elements, why I use a hybrid approach and the benefits of doing that, the cost-effective benefit of making up your own 3-part solution, as well as the fun of sort of taking control of the chemistry of your tank as well and playing with that. What I would end this presentation with is, if you're going to make your own 3 parts or 2 parts or trace stock solutions, the day before you start dosing, send off an ICP, and then a week or 2 into dosing, send off another one. And that way you can get very early warning to make sure that if you got your calculations wrong, you know before it gets out of control. So, calculations can go wrong. Just make sure you're covering yourself off. And look, the benefit of the daily measurements of alkalinity, calcium and magnesium through your tester, whatever testing you use, will help you keep that in check. Anyway, hope you enjoyed that presentation. Let's keep moving on. All right, so that's all we've got time for today. Hopefully you got something out of that. I enjoyed putting it together anyway. It was good fun. I love my water chemistry, and just as a bit of a background, you might be sitting there thinking, well, what does this guy know about water chemistry? Why should I listen to what he's got to say? Look, I'm not a chemist by trade, but I do have a PhD in hydrogeology, and I've been doing water chemistry as part of my research, my undergraduate studies, my honours, my PhD, and in my work career now for well over 30 years. As part of my research days, I used to prepare and collect my own samples in the field, and then I would do my own analysis in the lab. So, I've prepped and calibrated and run ICP, OES machines routinely as part of my PhD, and looked at water chemistry for many, many years. Look, I'm not professing to be a chemist, but I am very comfortable around water chemistry. It's something that I enjoy. And so, these sort of episodes are things that I want to do more of in my content, because it's something that I believe has an important part to play in successful SBS growth and colours and vibrance. That's today's episode. Hope you enjoyed it. I'll see you on the next one, hopefully. And in the meantime, may your reef thrive.